All right, let's go ahead and get started. So, can someone in the back let me know if you can hear me fine? Yes? Great, excellent. All right, good morning. We're here to talk about change at service scale. And if you're wondering about this cryptic name for the talk, we kind of wanted to share our experience with running the Exchange online service with you. And the way you want to think about this is Gayatri and I are just two mechanics, not engineers, mechanics. And why we call ourselves mechanics is our jobs every day is to pop open the hood and change the oil on the service, change the tire pressures, rotate the tires, do all kinds of interesting things to this service, which you could liken to a extremely well-tuned sports car. The one thing that makes our job interesting is that we don't get to stop the car. The car is barreling down the track. We must keep the car racing. We don't get to pit stop. We don't get to pull over to the side. That may or may not make our jobs a little bit interesting. And so we know that a lot of you guys have similar services. You're running this on-prem. You're running Exchange as part of your enterprise, as part of your company. And so you're probably wondering, I wonder how these guys do it. What could I learn from that? So we're here to share. And this is a large room, but we've got a sizable number of people. But we could also spend a little bit of time taking Q&A and working through details here. So before we move on, let me introduce myself. I'm Rudra Mitra. I'm a group program manager on Exchange.
I'm Gayatri. I also go by G and number 3. G3. I am the PM lead for Code Velocity. One of the many responsibilities that I have is to make sure that the changes are rolled out into our data center safely.
All right. So what we intend to cover today is take you through a little bit of background, how we got here. We'll talk about the types of changes we make to the Exchange install deployment that we have in the service. We're going to talk to you about the procedures we follow to safely make those changes. And this is a session where we're not afraid to tell you about when we mess up. So we will share with you a couple of our, what we technically call owies in the service. And we'll tell you how we got better at it from there. So yes, this is really the show behind the hood. One thing that I will sort of put out there is if you have questions, if we could hold them towards the end, that would be great. We have a lot of material to get through. But if there's something really, really, contextual, you want to get out right at the heat of the moment, feel free. Throw your hand up or just come down to the middle. We could talk about it. And I already talked a little bit about the disclaimer. It's a cloud-focused session. Gayatri and I really work on the deployment for the cloud, the change management for the cloud. But a lot of this will carry over to on-premises, and we'll try to tie it back as well. So depending on whether you're here to think about how you can improve on your on-premise change for Exchange, you'll get some out of this. If you're here to wonder about how do these guys do it online, is it safe, can I trust these guys, you should get something out of this as well. All right, so at this point, if you've gone to any of the other service talks or over the last few years, no surprise that we're running many, many data centers for this service, millions of tenants, thousands and hundreds of thousands of servers. So really, we have to be good at this. If we're not good at this, the problem ends up being that we impact customer availability, customer experience of the service. And so our jobs is make changes to the service in a mission-critical way well. Don't let it impact customers. Don't let it impact other engineers. Land this each time we make the change, which by itself is an interesting problem. But if you sort of think forward a little bit, we've grounded ourselves in 7 years of being involved directly with the service. And as we've run this, you know that the service itself is managed and run by Microsoft Exchange engineers. And so why should you have a belief in what we're going to talk to you about today? It's because Gayatri, myself, we represent our teams who are responsible for making these changes. We do it every day. We don't have folks that do it for us. We don't contract this out to other people. We are doing it ourselves. And the reason for that is it drives this cycle of making changes continuously, making sure those changes are good, and validating those changes. And so when we do mess up, when we do screw up, we've got to go fix it. That's our pagers that are the ones that are going off. And then we got to go fix that the next day so that we can get a good night's sleep. So the motivation is there when we get poked to wake up in the middle of the night. Which leads to sort of this last piece on the slide, which is the virtuous cycle of learning. We manage the changes. If I am responsible for making a change, I put it out there into the service at scale. I take care of making sure that I'm on call for that change landing. If there's a problem, and we do build that into our model, we'll talk about today, we have to be agile in responding to those problems. It just comes out of a philosophy of, we will try to be perfect, we will try to give you a good customer experience, but the best organizations plan for the eventuality that something might go wrong, and then we're going to fix that quickly first, and then we're going to figure out a way to get that into the product. We're going to figure out a way to get that into the service so that we don't have to repeat the same issue over and over and over again. It's the second instance of a problem, if it does happen, that we feel terrible about. If it happens once, we feel bad. If it has customer impact, we feel really bad. But if we let something happen twice, we flog ourselves. So tying this back to on-premises. So, Perry talked a little bit about this during the keynote, if you guys were there. But within the last year, we've really made a tidal wave shift in how we do engineering for Exchange. And for anyone who's been involved with Exchange for a long time, this is a point where you should sort of, it's like the third day of a conference, and I don't know about you guys, when I go to a conference, third day, I'm a little bit fatigued, and I'm a little bit, is this session any different from the first two? This is one slide that I hope you kind of sit up and say, wow, that's different. They've never done this before. And what this slide says is, we've moved to a single engineering code base for the cloud and for on-premises. And the strategy that we have here is that we now write code, build features, develop fixes for the cloud. We run it first for you. We run it for the service. We make sure we take that virtuous cycle of learning I showed you on the previous slide to weed out issues. And at that point, take that same code base and ship that to our on-premises customers as well. And so, to the question of, is Exchange committed to on-premises? Is Exchange committed to the cloud? We're saying from an engineering perspective, we're committed to both. We will take the pain of running these configurations first, these code changes first, and then we'll ship it to you. And we've really landed this change within the last few months with CU3. Most of you guys are familiar with the CU nomenclature, CU3. Then we've got CU4 or SP1 by its friendlier name. But the shift has really landed with CU3, and we are running that same code for CU3 with our millions of tenants. Our hundreds of thousands of servers are what's running that code. Make sure we get it done at scale. We feel like we have responded to the issues that have come out of that. And then at some point say, it is ready to go. Ship it to our best on-premises customers as well. And so the diagram on the bottom really shows you that it's what we call evergreen model. Run with a branch, get all of the Microsoft engineers working on that one branch, ship that code to the service that code in the service, and then ship it to on-premises as well. Which brings up the point of, okay, so I get this conceptual model of service, server, how you guys are trying to engineer for it. together. But what kinds of changes are we talking about today when we talk about doing it safely, doing it mid-flight? You know, this car analogy, kind of continuing it further. How do we service the car, keep it running? Well, we've got to think about feature changes. We'll talk to you a little bit about security changes, how we think about those. Bug fixes, we're making those all the time. You know, before you get these packages, these updates with bug fixes ironed out, how do we make sure those are the right things that we're trying to fix? And then there's also hardware upgrades and failures. Those are changes to the system. As a large-scale service, we are adding hardware at a rate where, you know, it's not just that we count the cycle time on months now. We try to count it on weeks. And it's about doubling how the footprint of the service looks. And so we've got to think about all of that new capacity landing that into a service that's running, and then keeping the system healthy. And so all of these are changes that are happening all the time in the system. So we've really internalized these three things. Change is continuous. Change requires validation. And this is the key one that we'll spend a bunch of time on, which is not just that, yeah, you're deploying CUs all the time and you've got security patches all the time, but it's important to be safe about how you roll those out. And you know this. You know this because when you try to apply an SP to the environment you're in, you know, you've always thought about, how do I take it to a staging environment first? How do I take it to a few servers first and then roll it out everywhere? So validation, but we'll think about a model for validation as well, and then this ability to engineer for responding quickly. It turns out that Socrates, amongst many other things, used to also think about cloud engineering. And back in the day, he said, the secret to change is to focus on moving forward and not on resisting the change, but also building the new. Now, I don't know if he was actually thinking about cloud engineering, but when I read this somewhere, I thought, I hope that's what he was saying. And we try to bring this philosophy to our strategy. We stage, we are very careful about how we apply changes to the environment. We have a platform for all changes, and this is something that is what keeps us sane. For all the types of changes at the scale at which we're making the change, we have to have ability to validate it, but we don't go building different validation for a hardware change versus a security patch. We have one way of validating these, whether it's new hardware, whether it's servicing a drive, or whether it's the next SP that we're rolling out or the next CU we're rolling out. And then we have responders and an ability to go fix screw-ups that are also common across all these. So Gayatri is going to take us through a number of these strategies and show us exactly how we partition our hardware and how we think about this.
All right, thank you, Rudy. You know, Rodriguez, one of the audience members said, there is a rock band after my name. I was super excited to hear that, and I hope, like, you know, there is a guitar playing at the back of the, you know, presentation. So let's get that energy up, everyone. So there are going to be a couple of big strategies that I'm going to be talking about. The first one is staging. Why do we do stage? See, all the changes that we roll out, it goes in ones of servers and then tens of servers, and then we increase it to hundreds of servers and then thousands of servers. Okay? The reason we do this thing is probably pretty obvious to many people. When the change scope is smaller, it is easy for us to, you know, remediate and move forward to the next stage. Also, importantly, each stage has been designed by us with a purpose, and we want to go super fast yet listen very carefully to all the signals that we have. And I'll be talking about signals also in the next few slides. So let's talk about how we roll out the change. So here is a backend change unit. Many people know that the change unit is a DAG. The DAG has multiple copies of the mailboxes, right? And for a front end, it's basically a capacity unit which you can safely take out of rotation, make whatever change you want and put it back without impacting availability. The interesting thing is in E15, the front-end CASBox and back-end mailboxes are not associated with each other. They can go in parallel. This gives us the capability to run the changes on these two server roles independently. Let's talk about how the exact change is actually happening within the change unit. So first we take one copy group. In parallel, we take one capacity unit. We roll out the change. We carefully listen for any abnormalities. Then we move on to the next and finish up the rest of the change unit. And at this stage, you can think of this as like rolling out our changes in ones of servers. The next one is multiple change unit. Now we are actually rolling out these change units in parallel, and at this time you are looking at tens of servers. So as I said, there are multiple front-end change units, multiple back-end change units. They all can go in parallel once you get that first level of confidence. The next thing is forest rollout, which is, you can think of this as rolling out in hundreds of servers, right? You go and roll out these changes on multiple of these DAGs, all of them in parallel. One thing that I would like to point out is these are cookie cutter rollouts. What I mean by that is there is single engineering code that runs on all of these servers that ensures there are absolutely no configuration drifts. So when you think about large scale, when there is no configuration drifts, it is so easy for us to debug the problem. Not only that, the second point is the number of servers that you take out of each of these change unit is also the same thing. So a copy group might be X number of servers, and it's exactly the same number of servers you would take out from another backend change unit. So you can imagine it's going to be so cohesive and consistent, and when things go wrong, we can actually manage our risks and plan our remediation appropriately. So the next thing is how we roll out these forests in parallel. At this time we are looking at thousands of servers. So all of these things go in parallel, and slowly we finish our rollout. And then our we call it worldwide complete when every server is actually done. So do you guys think it is simple, complex? Come on guys. Complex. Okay. We thought it is actually super simple from where we were coming up from, and we decided to keep it this model because we have developed the muscles to actually track various changes going on in this fashion, and we will slowly be evolving to make it much more simple in the future. All right, next I'm going to show you some internal dashboards or command centers. At this time I would like to pause and say that we talked about one change. At any given time there are multiple changes going on, and that too at extremely large scale. So instead of dealing with hey, how changes are rolling out in email or Excel, we invested deeply on this technology. Okay. So internally we call this thing release pipeline view, and what it shows is the different changes that are going on in parallel. The rows actually shows the change that we are rolling out, and the columns are showing the stages in which it's actually getting rolled out. Let's take this example. So this has passed this stage. The next one, it has passed this one, and the next one is coming up in this particular stage. And here is an example of a change that's rolling out in progress. One of the cool things about this tool is all these stages that you're seeing, they are all from different environments. We decided to consolidate everything in one place so it's easy for us to manage the rollouts once it starts. Now, a little bit detailed view. If you go here and click on this, in the interest of time, I have actually opened it up earlier. It shows this view where it says, hey, here is the role that we are rolling, here is the region, here is the DAG, and what is the percentage it's actually completed. And this view helps us in finding out which DAGs are falling behind for various reasons, and lets us react to those issues quickly. But ideally, we are expecting all of these DAGs to move in parallel, all of these front ends to move in parallel, but it's not always the case. Sometimes it could actually fall behind, and we have to push them forward. And there could be hardware reasons or network connectivity problem that might be transient, or even a big incident like a cable cut issue in between two regions. The next view that I would like to share is this. We have many optics that we have built in for tracking how rollouts are happening, so we can do the offline analysis. The view that I showed earlier is more along online view. This one, this particular view actually shows the failure percentages. So to give you some insights into it, you take a machine for your rollout, you need to get this machine from this state to that state. And in order to do that, there are so many workflows that you need to run. These workflows may fail sometime, may retry multiple times, sometimes it might retry indefinitely, but this kind of optics lets us ground ourselves on how things are progressing, so we can optimize and make it better in the future. Going back to the presentation, I had a backup slides in case there were network connectivity problems. All right. Let's talk about the rollout automation system. So as I said, for all these changes that are going out, we don't want to be reinventing how you stage that rollout. So we decided to have one staging mechanism, and we invested that on one automation platform. In yesterday's talk on behind the curtains for running Exchange Online, Vivek had actually mentioned about Central Admin. So that is the platform piece that we all use, and it actually manages all the activities that are going on in the data center, and this automation piece is built on top of that. And the cool thing is this system knows about the capacity constraints of the change units. So we have predefined all of these things, and it notes what is the choke point and things like that. And there could be operator errors, and there are engineering built in a defense in depth for safety nets on so we don't take too many copies of the database at the same time, or too many capacity units from front end at the same time. So there is lots of defense in depth built into the system. The next is access. That's another interesting area. So once a change is ready, we need to roll that change out. How many people do you think have access to the data center at any given time? Any guesses? 5, 10, 15, 20? Take a guess. 5. So at any given time, it is 0 to at most 2. So the way we do this is like, when the engineer is actually ready to make that change, he or she would actually get or request elevated permission using the Lockbox technology, which was described in the Monday security session. And once that request is approved, that person logs into the data center, issues a command, and gets out of it. That's all it is. The rest of the activity is all done offline, and we have lots of engineering built in to take care of our offline activities. And of course, we need lots and lots of tracing for debugging and auditing purpose. If you're not logged on to the data center, you have to invest in all of these things, and it really helps us identify what is going on within our automation system and etc.
Okay.
Any questions at this time?
So there's a couple of key points to make here before we move on to validation. One is that at the scale at which the service runs, everything has to be automated. And what Gayatri showed you was the command center that helps us manage all of that automation that's running. Keeps track of all the changes, keeps track of all the scopes that we're running at, keeps track of all the successes and the failures that are basically being run at any point in time. That's one, all automated. The second key point that she showed you was you have to invest heavily in being able to visualize and sort of see the real-time views of what change is happening at any point in time. Whether things are going wrong, whether things are going right, you do need to know that, especially if you're trying to run many things at the same time. And so we have invested heavily in the dashboard. The world premiere that you just saw of the command center is something very much built, tuned to the service. But underneath it, it is PowerShell against the servers. It is the standard stuff that we are shipping to our on-premises customers as well to keep track of what a server state is, what services are running, what we get back from the server in terms of processes that are running or not. So it can be done. We have decided to invest in the engineering to pull it all together so that we can do it at high scale. So that's number two. And then number three is we think it is very important for people to not be able to make changes to servers without being very constrained. That's where our security folks get very nervous when we try to make changes to servers across the engineering team. So we have to scope it down. We have to take limited amounts of time. We have to describe very well what we're doing. We have to be in and we have to be out. Because anything other than that, and the security folks come knocking at our doors. And so we want to make sure that things are kept very, very scoped. Yeah, I think there's a question.
When you talk about changes that you're making to the system, are you actually patching servers, or are you deploying a new server OS? And, for example, you stage up CU3, instead of rolling out a CU3 onto a CU2 box, are you literally just deploying a brand new CU3 server? Or
Great question.
Are you actually going through and dropping a hotfix and whatnot? And have you found any, which way is better?
Yeah. Yeah. So the way we are actually rolling out changes is from scratch. Every time we make a change for rolling out brand new features, or the change that you saw in that one, it's nuke and pave. We get the OS installed and we get the new bits out. So everything is clean, all the time. There are cases where we roll out patches or bug fixes. In those cases, we don't do such a heavy lifting operation, in which case we just drop those bits and make sure that all the signals are positive and it's not failing on us, and then we do the staged rollout to get the remaining changes out. So in general, yeah, we actually do the nuke and pave, but we also have other classes of rollouts. Yeah. All right.
One quick question.
Yes.
Is your workflow driven through Orchestrator, or what's your backend that's actually doing that?
So it is basically on top of that central admin. It is built on Microsoft Workflow Foundation right now, and we are trying to move on to the next technologies and stuff like that in the future.
To what Gayatri said, I would say certainly Workflow Foundation is at the core of it. PowerShell is the remoting mechanism against the servers, which you must already be comfortable with. And then the sauce that we apply on top of that is at scale how to divide that up across the globe, right? Do we allow all those workflows to be run from one point? Do we allow that to be run from multiple staging points so that we don't have single points of failure, redundancy? So a little bit of it comes from the fact that at scale, the orchestrator just needs to have high availability characteristics itself because it is the one brain running the service for us. As well as, it's the brain not only doing change, but also hardware repairs, new hardware. So we try to bet on the same thing for many, many things that we do. So we have shared technology there.
All right. Let's talk about the next strategy pillar that we have, validation. Why do we do validation? It should be pretty obvious. We want to find the issues in smaller scope before it gets on to larger scopes, because finding and fixing the issue in smaller scope is actually easy and also cheap. As it goes, it becomes very costly to fix all of these issues. And number two, we want to find the issues first before our customers tell us. So we run all of these validation/signals all the time, and we will discuss that. So after every stage, we run these signals and try to wait for green or red, and when we have the green, we move forward. When we get the red, we actually don't move forward. We wait here and find out what's going on, try to understand the issue better, and then once we understand, remediate, we move forward, and it slowly progresses to other stages. It definitely gives us the confidence to move further. We'll talk about signals next. So there are many signals. As you heard, there are so many changes going on. Instead of building separate type of signals, we have a slew of signals that run all the time. And number two is we triangulate more than one signal. This is to prevent false positives from happening. Just imagine you get woken up at 2 a.m. for a false positive issue. You're not going to like it. So you go back and we refined all our monitoring and the signal platform and made sure that we triangulate among multiple signals to have high confidence before we alert anybody. We invest a lot on active and passive monitoring. Active monitoring is the same thing that even our on-prem customers have. It's the synthetic probes that run all the time, and the passive monitoring is real user data. And this is something that we also have, and we predominantly rely on active monitoring for our validation. And some of the examples of things that we look for is availability, latency, errors of functionality, and importantly, we have even the performance characteristics available in certain stages. And then we also look for user experience, for the change that we have rolled out. And last but not the least one, we also have a safety net of listening to customer call volume through support. This is to make sure that we are not blindly moving forward, because there might be some problems in our signals also that we are constantly evolving. But we have fairly high confidence in our signals, so we also have a safety net just in case. And customer signal on O365 TAP. This is a brand new signal that we have actually introduced. In the previous years, we had TAP programs where customers signed up for the program to experience new features, new big features, right? Now in the online world, we have introduced the O365 TAP program, where interested customers can sign up for the program, and we actually roll out these changes in a very controlled way to these users. And we listen for feedback, and that drives towards product changes in the future. All right.
So before we move On the previous slide, if you have not yet heard about the Service tab, there are a certain set of folks that are sort of floating around the conference that you can reach out to,
Yeah.
or we can help you connect to them. Larger functionality feature changes that we make, Gayatri alluded to this, we can now figure out how to get that to a certain set of folks as opposed to our entire online population. And so we do want to have folks sign up for that. If you want to be the first to see a feature, if you want to be the first to see a bigger change that we're about to make, this is the way to get into it. It's another signal where you can influence the feature, give feedback back to the service, and in turn back to the on-premises product that will ship. So for example, groups, one of the headlines that we've talked about at this conference, a certain set of folks will get that first. They'll be able to try it. They'll be able to give feedback on it, on their experience. We'll improve it, and then we'll send it out the door to the entire population. So if you're not as part of this TAP program, but you've seen TAPs for the on-prem stuff, might want to think about this as a way to look at features before everyone else gets them.
All right, let's talk about what happens when the signals fail on us. First, we stop the train. So when things are not working the way we anticipate, we stop to make sure that the damage is controlled, and we try to figure out what is going on. And the first thing we do is, we page the engineer that has the signal failed. And the next thing is that engineer tries to isolate the problem. He or she can actually involve other people as needed to resolve that issue. Sometimes it is simple, sometimes it's very complex. And once the issue is identified, there is no shortcuts to rolling out. We again, go through the stage rollout. We listen to all the signals very carefully. And then we also tell the underlying platform or the fabric that this particular fix has been rolled out, so that any hardware that is probably sleeping due to some hardware failure or some other reason, when they all come back online, they take this fix and back in rotation at that time. So the interesting thing is all of these activities, starting from stopping the change train all the way up to resuming the change train, is happening 24/7, 365 days. Now comes the next interesting part, the learning, right? So as Rudy mentioned, we do not want to make the same mistake 2 times. We have vested interest in finding the root cause, because we do not want to get woken up again at 2 or 3 a.m. So we try to have lot of rigor on what went wrong, and why did we miss this thing in the previous stages. And we have separate forums where we talk about our engineering plans to fix that issue. And until that issue is resolved, we continue to pound on that thing and make it really robust. And the last 2 activities will happen during business hours. All right. Now, going back to the same command center, I'm going to show you some of the signal related information. See, you might have been wondering what those greens and reds were. So those are the signal information that we have. So if you see here, these have passed and they have positive green signal. So we moved on to the next stage. Here is an interesting one. We got red. So that basically means some of the signals failed, and it is rightfully failed at that stage, because that's an environment where we try to find as many issues as possible, so the engineers can quickly react and get on with their fix before the next stage rollout starts. And here, if you look at validation status, past missed issues, we have exhaustive list of signals that show up once we say it is passed. And if it is failed, it will actually tell you what signal has actually failed. There is a slew of things here. The next thing is the missed one. So the missed issues actually shows, before that, I'd like to go to this interesting one. Okay, the missed issues is actually from this particular change. You see it is green, but then we found a couple of issues after it actually went to the next stage. And if you look at that problem, it is these two issues. And the key thing that I wanted to talk about at this time is, number one, any information associated with the change is all in one place. So it makes it so easy for the engineers and the associated people to go and look for that information from that place. Number two is the same thing that I mentioned. Once this issue is found, like all that engineering rigor, updating the status, all of these things happen here so that we keep track of which issue failed on us, how are we reacting, and things like that. Okay. And by the way, that is the performance scorecard, which the performance team will actually be talking more at the 1 o'clock session. This is an interesting signal which we have, and it can be run after certain set of machines are rolled out, which is once there is like hundreds of servers and things like that, you can have a better understanding of the perf characteristics. And it's a super cool signal that we have developed. It definitely has helped us dramatically on taking certain, prevented from taking certain perf regressions forward. All right, next we will talk about hardware changes. Why is hardware change a big deal, right? So within a change unit, as you can imagine, we expect full availability, so we can take few machines out of rotation and still maintain that availability. Among that constraint, if more machines are off, it's very hard to roll out the change. And I'm going to show what we are going to do about that. See, here is the underlying view. There is hard disk failure, disk controller failure, fan issues. These are problems that all of us face all the time, right? And in the service model, we have focused on reduced COGS and zero hardware redundancy. There is no redundant power cards, etc., right? Now, fault tolerance for all of these things is built within software, and you guys know very well about it. High availability talks would have said a lot about that story. And hardware failures do have a big impact on change. And the fact is we do not want these failures to block change from rolling out. And number two, all of these issues once identified takes a lot of time to get fixed, because it may have to go to the hardware vendor and it might take back and forth until the issue is fully resolved. We do not want to hold these changes from happening until those machines are actually back. So the way we do this thing is all hardware failures are monitored by the same signals that I described earlier. We have excess capacity within the scale unit of backend and frontend, so that we can afford to take a few machines offline for hardware failures. And because we can roll out those changes without being blocked, these repair actions can happen asynchronously or lazily. And when those machines are back online, they actually come back to the same baseline as the rest of the servers. So if there have been any patches or anything that had happened, these machines also get the same code. New capacity is another very interesting topic with respect to change. So we have new mailboxes that are being provisioned all the time. There are existing mailboxes, and the growth pattern of existing mailboxes is very random. So there is a need for new capacity all the time. And when these new capacity comes, they all land in big increments. And it has the potential to, disrupt the service. And our goal is to make sure they all are well managed and it does not disrupt the service. So we have a pipeline for adding new hardware. So you can imagine, right? Like when you add a new hardware, there is, hardware vendors, there are multiple teams involved in it. But this is a core scenario that the team focuses on to make sure it is seamless. And we bring in these hardware to the same version as the rest of the servers in the data center. And you would imagine that new hardware may not have issues, but they also have lots of problems. And the same signals that we used to detect hardware issues are also used to detect new capacity hardware related problems. And with that, let me pause and ask if there are any questions. Yeah.
When you said that you brought the servers into the same code base, the change unit, is that it goes in patched? So if you're adding new capacity, you're adding it to the patch value. So if you're halfway through a change cycle in that particular change unit, you're bringing in the new change, correct?
Yeah, when you bring in these things, they are all with the latest code, latest patch, everything, and it comes in. And then the underlying platform, remember I mentioned the underlying platform is notified that these are the patches that have been done on the rest of the data center. So the platform knows that it has to be applied on to the new machines as well. Yeah.
Well, one of the most common scenarios is we've sent some hardware out for repair. Security patching came through after that. We've applied it everywhere else. We got to bring the hardware that was being repaired patched in. We don't want to knowingly bring it in, unpatched with the patches we just applied. So we'll take the time to go patch it and then bring it on, not just the code changes.
Do you, when you send hardware out for repair, you said you had excess capacity. Do you roll your excess capacity into the production stage and then bring your repaired hardware back into your spares pool? Is it like a rolling?
It is, and I would certainly refer to our performance talk we have a little bit later today as well. But our performance team also spends a lot of time modeling how much hardware we should have on reserve. To the point that you made, to keep it rolling, we've added the hardware with the excess capacity on it into production when we brought it in the first time around. And so when the hardware is out for repairs, we've still got enough left to run a healthy service. Now, a couple of points were also alluded to before. One was, we are taking capacity out all the time for patching, deployment, fixes, whatnot. We build that into our model. We build that into a predictive model where we say we need 30%, 40%, 50% extra hardware to account for this rolling cycle, as you described it, of pulling things out, patching them, bringing them back in. That's number one. Number two is we're also bringing this stuff back in, or pulling it out and then fixing it and bringing it back in, with the active monitoring and the passive monitoring running all the time. And so that's the signals, sort of quote unquote, that are going off all the time, which is that if you take a server and you patch it and you don't wait for the signal to fire and bring it back in, who knows what state that's in. Maybe something else failed while we were sitting on that. And when you're talking about hundreds and thousands of servers, that actually happens all the time, which is we'll pull a server out, we'll apply a patch, the patch requires a reboot, and everyone knows every time you reboot a server, your probability of that hardware failing goes up just a little bit more because it's gone through a power cycle. And so we'll patch a server, power cycle it, and it won't come back up. In our old model, our learning across the last 7 years has sort of taken us through, we would bring that server up after patching and throw it right back in. And once we threw it back in, not working. Something failed, hard drive failed, disk failed. So we'll wait for a cycle of validation to go through on it, get the signal back that's green, and then bring it back in. And so some of the abstraction that we're doing here at this talk is, it really is a orchestra of all these failures, repairs, and validation that are happening at this scale, which which is why we spend so much engineering behind it, just tracking that. And so for the on-premises side of things, what we want to make sure is the investments we put into monitoring, right? We want to drive our monitoring team to get better at that validation, because if they don't get better, our jobs get harder. And so there's a cycle between the teams. Performance, if they don't have a great model, then we don't do the right thing in terms of pulling out servers. Our first, an anecdote I'll share from a couple of years ago is we were all the time for deployment trying to go fast and pulling out a bunch of servers that we want to go apply change to. And the perf guys are just down the hallway would keep running down and saying, well, the service isn't healthy. You took too many servers out. And we're like, yes, but our jobs are to go put changes on as many servers as we can. And so we were constantly going back and forth, till we actually got wiser and put that into the orchestration itself, so that it's not humans we're relying on. We are actually letting the software decide for us what is okay to take out and then put back in. And thankfully, we now have a beautiful relationship between the change team and the performance team.
So just one question with regards to why you're doing things the way you're doing them. You're reloading a box, you're reprovisioning a brand new code base on it. Have you done that because it's faster, or we all know that upgrading stuff just always doesn't go as planned? So is it because, I guess what I'm trying to find out from you, are you saying is it's a recommendation to stop applying CUs and just start from scratch?
No, certainly not. The model of applying CUs on top of code that's already on the box, fully supported, fully done in the data center as well, and certainly for hot fixes and patches, we run through that process as well. The optimization we have done in the data center is to say that when we have a large number of servers that we're trying to do that on, it is okay once in a while to go nuke and pave the box. And why we do that is to just say any configuration drift that has happened because someone touched the machine, someone took some reactive steps on it, get blown away. So it helps us. You should think about it as every once in a while get back to a known equal footing on everything, but that is not to be interpreted hopefully as our new recommendation for CUs is re-image the box to the OS. Absolutely not. We support both. We do both in the data center. But it's not a bad idea once in a while for on-premises as well to think about, hey, how long has this server been running, and do I have the, whether you call it the investment that I want to make, the wherewithal to sort of say, yeah, I'm going to move everything off to a different copy group, clean up this box, and so it depends on the scale. How many people are touching that machine? How much drift do you think you have? If for my Exchange server that I run at home, I haven't nuked and paved it in a long time because I know I'm the one who's made the change. I know exactly what I've twiddled on it. The problem is Gayatri is always on the servers in the data center doing something, and I'm deeply suspicious of her. So, but every once in a while, it just makes sense for me to blow everything away, put it on, move the active copies back, and I know I have a good system. At hundreds and thousands of servers, that's just good practice to do every once in a while. Keeps the patient sort of in a known baseline state. Sort of a long-winded answer, but I hope I answered the question.
Yeah. All right. So we talked about few topics: staging, validation, right? And just think large scale and continuously growing scale, right? We have tried our best to build those core muscles in running our service. But every time when these capacity lands in big increments, the strength of those core muscles are tested, and we know it gets weak. So this kind of learning from mistakes actually helps us understand what is the different aspect of the muscle that we want to go exercise and get that thing strengthened, right? So I'm going to share a few examples. These are issues that we messed up, and what did we do and what did we learn. All right, this is a scenario where the database failover happened, and then the cafe connectivity was pretty slow between E14 and E15. So there was slower experience. There was degradation on user experience. The issue was actually fixed pretty easily by retrying the request with the correct new backend server, and all of these changes were also sent to on-prem customers as part of SP1. This is an example of where any of the functional, performance, scale improvements that we make in the system all accrues to the server as well. So if you recall the forking picture that we showed, all these fixes are tested in the cloud first, and then they all get aggregated and sent to our on-prem customers as well. The next issue was a firmware problem which affected network connectivity, and that too in the Europe region. And what happened was, the front end rightfully connected, reconnected, tried to reconnect, but there was a problem in the reconnect logic. And after fixing the problem, we were trying to find out hey, what happened? Why did we miss this thing? And we went back and did that virtuous cycle of learning and incorporated the signals and did the right level of engineering so that this issue doesn't come up again. The next problem is the Mac Outlook user were unable to access the mailbox using the Outlook client. And this was only on certain conditions. It was a very interesting issue that we found. And the problems were we were not able to load the saved content, and when you try to delete the message, it was so slow, etc. And what happened was the team was looking into the problem. They enhanced the logging, and they also fine-tuned their throttling logic. And again, we went back and did what was going on, why did we miss this thing in the preliminary stages? And the team found out that there was missing signal, and we went back and added that into our system. The next case study is another interesting one, where we were using the encryption and signing certificates in the case of OVA, in the case of Outlook, and when you try to open it up, it actually opens. But in the OVA scenario, we just used one of them, and it was good that we found this problem in SDF. And the thing that I would like to show you is this issue was found on 12/18, fixed very quickly, and it also went to the on-prem customers. And this is an example where we were very agile in responding to issues, and another example for where all these issues are found, tested in the services before it goes to the server, for the on-prem customers. So with that, I will give it to Rudy.
Any questions on the case studies we shared, or sort of any general learnings you guys want to talk about? The thing I take away from the case studies was that every time we write a bunch of new code, before we ship it to on premises or even to the service, we want to make sure we've done a good job running it ourselves. We want to spend some time with it because we have great validation, we have great folks who are trying to test and validate stuff. But if you think about the Exchange ecosystem, with all the device types, all the protocols, all the scenarios that we support as a server, it's just a massive matrix. And then you start to throw in things like, different hardware underneath it, different network gear in front of it, different proxies that are possible. It's just an expanding matrix that you always have to keep track of. And so there's two approaches to it. One is to say, we'll just get better at writing test cases and QAing this stuff. Or the other stuff is to say, no, we'll run it ourselves first. And we'll learn some stuff along the way. And hopefully what we can do is, tie back to many of the concepts we talked about. We will limit the scope of that problem. We'll not make changes for 2 years and then throw it into a release, ship it to you guys and say, okay, run your mission critical stuff on this now. Trust us, it works, right? Which we've done for many years, and thank you for trusting us. But part of that is we owe it to you guys to actually run it ourselves for a while, right? Get some of our biggest tenants on this, not just Microsoft, but some of the folks that are in the cloud running this stuff for them, and making sure we've really worked through it. Is this Windows Phone behind this proxy with IPv6 working fine against the server? You know, some of it is a test case thing, and some of it is you just got to run it over those networks to see what happens. And so the test cases, the case studies are not just an admission of, you know, we screw up, and yeah, we try to fix things, but it's also an admission of the ecosystem is just getting bigger and bigger and bigger. Trends like bring your own device, multiple protocols, messaging everywhere means that you cannot realistically test and QA everything. You have to get good at seeing it in the ecosystem, being able to respond quickly, and then get it out to the service, which we should be on the hook for. We as engineers need to be frontline looking at it. And then if the promise lands by the time we ship it to you, we have bulletproof tested it, and then we're sending you something of higher quality. Now that's the strategy, that's the mission, and we are working our way towards sort of landing that in a full way, and we'll keep working on that till we get it landed fully. All right, so in summary, sort of we really want you to take a few things away for both on-premises as well as our sort of promise to the service and then accruing back to the server. We're going to do many types of changes, but we're going to get good at one way of doing it. What's the one way of doing it? It's what we described. The methodology is bet on software on top of hardware or commodity hardware, and more, it's the bet on the HA story that we have, right? We ship it to you guys, we run it with the data center. Betting on HA and betting on that model is the way we're going to make changes work. So that thing gets better. We're going to have one way of validating these changes, which is, yeah, we have a bunch of passive signals we look at, which you can look at too, which is you apply a set of changes to your servers. Do your customers call you more, or do call your IT department more or less? That's just, you know, we've tried to put some engineering around the procedures. A lot of folks have told us that they do. But really, the monitoring that we ship to you guys is the monitoring that we call signals that we want to run in the data center. And if we can bet on that thing for our changes and validation, then we should put it on a treadmill to get better and better. Otherwise, we're going to, just like we talked about the performance sort of kind of a joke that we had, we're going to keep walking down the hallway to that monitoring team and say, your stuff doesn't work. Get it better, or it's great, but this scenario you keep missing, so that we don't get woken up. So we're going to keep that life cycle of conversation going back and forth. We're going to triangulate multiple signals. We highly recommend you do as well, which is if you're making changes, don't just wait for whether the monitoring passes. Think about other ways you can incorporate. Do your support calls go up? Do they go down? Do you see more error logs or less? A lot of folks do this. A lot of Exchange admins do this already. A lot of IT departments do this already. But triangulate a few of those, and especially if you have a big on-prem install, you'll do better at sort of scoping change as needed. Things happen. We try to be agile to those mistakes. We try to contain those. Scoping stages, super important concept. Not only just for a service, but for anyone who's applying changes to servers. You got to think about ways to segment it. And where we're not doing a good job of giving you ways to do changes at a small, finite unit first before you take it broad, tell us. Give us that feedback. Because we do need to think about non-meshed sort of intersections between all of our servers or server roles such that you are forced to apply changes in big bang changes. If you do, the problem is responding, recovering is just that much. You got to lift that many more rocks to kind of go back and fix that. So that's something that you should give us feedback on making the architecture better, but you should also adopt as a procedure. And whether you sort of see this or not, the hood we're lifting up today is we're really saying we're making, there's a lot of cloud and next on-prem server sort of feature discussion, but we're connecting the two. We're not sort of treating cloud as separate and server as separate. Those aren't separate strategies for us. There's a choice that people have to make, which is which one am I betting on? But we want to get the quality, procedure, code base sort of intersected between the two so that as engineers, we're not making discrete choices for you so that one gets better quality and one gets worse. We are even doubling down on the quality for both. And so we want each to accrue to the other. Thank you for your time. If you have any questions,
Yeah, any questions?
you can talk about it as a group, or you can come up afterwards. This is Gayatri again. I'm Rudy. We'll be on the floor in a little bit. You can find us there as well.
Yeah.
Thank you again.
Thank you.